Okay, 2.8 C. Okay, elementary algebra, we are ready for example number 9. And we have we have 2x minus 3y is less than 6. Solve for y. Okay, remember a couple lessons ago, I don't remember how many it was, I said when you have two variables, that is called a formula. Okay? And remember, when you have two variables, you cannot solve for the x or the y when you only have one equation, in this case inequality, because it's an inequality sign instead of an equal sign. We cannot find out what value x is or what value y is. Can't happen, because I only have one inequality. If I had two, I could, but I only have one, so I can't solve. So I can just kind of move things around a little bit and solve for y. So I'm just trying to get y on one side of the equal sign all by itself. Okay, so first thing again, we get rid of the things that are furthest away from the 3y. So we're going to get rid of that 2x. So I have negative 3y is less than 6 minus 2x. All right, we did not switch our sign here because we didn't divide or multiply by a negative. We just subtracted 2x there and subtracted 2x there. That's all we did. And 6 and 2x, we can't combine those because remember, terms are only combinable if they have the same variable and the same exponent on the variable. And since 6 doesn't have a variable, we can't do anything with it. Now I'm going to divide by negative 3, and I'm going to divide again the whole thing by negative 3. Alright, so notice what I did. I divided by a negative 3, so that means my sign changes. Don't forget to make sure your sign changes. Alright, now what we're going to do. And we did this earlier, but I'm going to remind you what we're doing. We're going to split this up into two fractions. This whole thing is over negative 3. The 6 is over negative 3, and the 2x is over negative 3. So I can write them. I can split those fractions up and keep the symbol right there, that minus sign there, and I can split those up. All right, so let's go ahead and simplify this. Y is greater than 6 over 3 is 2, and then we have a negative. A positive over a negative is a negative. We also have a minus minus, so that means two negatives give you a plus. And now I'm going to just switch these around. So all I'm going to do is I'm going to put the 2x over 3. You always put the x first, and then the minus 2. And that ends up being our answer. Okay? So, look at that a little bit. I did kind of a lot of stuff. I didn't do anything new with it, but I did kind of a lot of stuff in this one. So, make sure you understand exactly what happened. All right, let's look at example 10, and that will be the last of the lecture, and then we'll go into some of the problems. And example 10 is an application, or that's the nice way of saying an evil story problem. The sum of two consecutive odd numbers. Okay, two consecutive odd numbers. One is going to be x, the other one is x plus 2. Remember, consecutive odd, consecutive even. If there are two of them, it's going to be x and x plus 2 all the time. Okay, so the sum of two consecutive odd integers, which means if we add them together, what does it say about them? If we add them together, we will get a number that is at most 28. Does that mean it can be 28? Yes, but at most 28. It can't be any bigger than 28, so therefore it has to be either smaller than 28 or equal to 28 if we were to add those two numbers together. So that's why I got the inequality that I did. All right, so let's go ahead and solve this. X plus x is 2x. subtract 2, subtract 2, divide by 2, divide by 2, and we get x is less than or equal to 13. Okay, so there's our answer. Now we can take this number and plug it back into our original one and figure the answer out and figure out if that's true or not. But all we found out is that 13 is a possibility. The second number is going to be 13 plus 2. So one of the numbers is 13, the other one is 13 plus 2, which is 15. Okay, so those are possibilities. It says that if we add these two numbers, we will either get 28 or a number smaller than 28. Will we get 28 if we add those? Yes. So our answer is going to be x is less than or equal to 13, or x is less than or equal to 15. So this is my first number, and this is my second number possibility. Okay, has to be less than 15. My second number has to be less than or equal to 15. My first number has to be less than or equal to 13. Okay, so those are my possibilities for number 10, and I'm done. All right, so let's look at some of the problem sets for 2.8. So looking at the problem set for 2.8, I'm assuming that you won't have too much trouble with most of the ones from 1 to 24. But I am going to do, let's do number 24, just because that one is a little tricky. Okay, so remember, this negative, you can either leave up there on the 3 or move down there with the 4. Your choice. Doesn't really matter to me. Right now, let's just leave it where it is. So, we're trying to get rid of this here. So we're going to divide both sides by negative 3/4 divided by negative 3/4. So we divided by a negative, so we're going to switch our sign around. So this all goes away. Switch the sign. Okay, 6 divided by negative 3/4. And what I do sometimes is I like extra darken this line here, so I know that this is the division line over this fraction, so that I don't, like, is this 6 over 3 all over 4, or is it 6 over negative 3 over 4? So it just helps me to remember. All right, then remember we take the bottom fraction and we invert multiply. So we just do this times negative 4 over 3. And we write that as 6 over 1. So y is less than negative 24 over 3, which is equal to negative 8. So y is less than negative 8 for number 24. And what does it say? Solve the following inequalities using the multiplication. I'm just trying to see what kind of way they want the problem written. So we've got y is less than negative 8. Oh, it says graph. So let's go ahead and graph. And I'm going to put the 0 clear over here. So there's negative 8. And it says it's less than. It does not say it's equal, so it's an open circle, and it's all the numbers less than negative 8 to the left of negative 8. And there's your answer. So for 25 to 50, you are supposed to solve. So let's do 50. Okay. Let's go ahead and distribute that 6. Okay, so I multiplied this, I distributed negative 6 here and got negative 6x. Now I distribute this negative 6 times negative 3 and I get plus 18. All right, so what is the smallest x? I want to try to get my x's together. So I take the smallest one, which in this case is -6. That's smaller than -4, so I'm going to move that over here. So I'm going to add 6x, add 6x. So that goes away. And I have 8 plus 18 is less than or equal to, add those together, 2x plus 12. Let's add those together. Okay, again, I'm trying to get the x solved, so I'm going to subtract 12, furthest away from the x. This gives me 14. Okay, so remember, you do not switch the sign because I'm subtracting 12, not multiplying or dividing by a negative. Divide by 2, divide by 2, so 7 is less than or equal to x. Or, if you want to switch those around, x is greater than or equal to 7. Okay, so that's number 50, and then it can be written as x such that x is greater than or equal to 7. And it looks just like that. That's how you would solve that. All right, continuing on. 51 to 58, these really aren't any more difficult than the example we did earlier. That was, oh gosh, what example was that? That was example 9. So if you go back and look at that, you're solving for y. You've got two variables. Can't find the answer. You can just solve for the y, move everything around so that the y is isolated or by itself. And that takes us up to 58. And that's as far as we're going in this lesson. We're not going to do all of the story problems. We'll just kind of leave things as they are with this lesson. And that's it for lesson 2.8 and chapter 2.